Great, a warm welcome to all of you. Let's see if people are joining us step by step today, and then we'll start officially. Welcome to everybody to our city workshop supporting city-scale greenhouse gas emissions inventories, opportunities and challenges. This is our second workshop for the project CO2, a prototype system for a Copernicus CO2 carbon dioxide service. So a warm welcome to all of you. We've got a wonderful lineup of speakers, and I would like to quickly run through just a few house rules so that we can start. So the webinar will be recorded. We have interpretation available in English, Portuguese, and Spanish. You can set the button at the bottom where you have the bar. We will be using the webinar chat as well as our Q&A piece, and then definitely want some interaction. So please do raise your hand if you wish to ask a question. We have short times after the interventions for a clarification question, but the bulk of the discussions will be, of course, at the end of the webinar. And since we've got a very intensive session ahead of us, I would now run to our Menti questions so that we could see who are we talking to. So just pausing my screen for the moment. And we would love to hear from you who is in our audience. So if you could please complete the Menti survey, and asking my colleagues to pull that up in the chat with the code, then that would be fantastic. And I think we can also share the results as soon as people have tagged which organization type are they engaged in. Okay. I'm not sure if we have results ready yet, or there we go. Okay, we're still waiting for people to populate the Menti. And speakers, please feel free to add as well. Great. Maybe we can look at the results a little bit later. Again, as I assume people will still be joining the rest a little bit later as well. Okay, if you can release the screen, then we can quickly run through the agenda. Thank you so much. And sharing my screen again. There we go. So we've got an intensive lineup here. So I'm setting the scene. I'm your moderator. My name is Marijke van Staden. I'm the director of ICLE's Carbon Climate Center, based in Bonn, dealing with carbon and CO2 and other emissions. And I'm delighted to have a wonderful range of colleagues from different entities and organizations joining us. Let me quickly, so we will have several presentations, a brief break, and then at the end, a discussion with all of you to also get your perspectives and impressions as well. Let me run to our speakers. So you see myself there. Then we also have Richard Engelen, Deputy Director of the Copernicus Atmosphere Monitoring Service at the European Centre for Medium Range Weather Forecasts in Reading in the UK. Very happy to have Rovana Bortolini as our city representative speaking from Porto Alegre. She's the Director of Sustainability Policies and Projects in the Secretariat for Environment, Urbanism and Sustainability. Dr. Frédéric Chevalier, Senior Researcher at LSCE in Paris. Dr. Lucas Emmeninger, the Head of Laboratory at the Air Pollution Environmental Technology, EMPA, in Switzerland, in Zurich. Dr. Philip Kaisch, Senior Researcher of the, also again, LSCE in Paris, in France. Dr. Roxana Petrescu, the Senior Environmental Researcher at the Vrije Universiteit Amsterdam in the Netherlands, and Dr. Glenn Peters, Research Director at the Center for International Climate Research in Oslo, in Norway. And since we're in all these different cities, we also thought that let's convene online to also have a good chat. I wish to set the scene to help just frame what are we looking at and where is ICLE's interest in looking at robust greenhouse gas emission inventory at the community scale. Now, the purpose of this meeting is very much to look at how we can enhance city-scale greenhouse gas emissions, or as we call it in the Global Protocol for Community-Scale Emissions, the community-scale emissions. So that could be any territory that we're looking at, and making sure that we reduce emissions and track progress over time. We have to improve the way inventories are being developed. We have to ease the way inventories are being developed, and looking also to see how we can manage and deal with data gaps. And in particular, the conversation today is on the use of satellite data and atmosphere models that are available at increasingly spatial resolution. So this is an exciting new evolution, and we wish to discuss if new services are needed and what these could be from your perspective as well. For those of you who do not know ICLEI, brief introduction. Our full name is ICLEI Local Governments for Sustainability, known as ICLEI in brief. We're a global network of more than 2,500 local and regional governments in 125 countries, and these governments are committed to sustainable urban development. So we work with them on policy, but also action, and including developing greenhouse gas emissions and reducing emissions at a rapid rate. We have 600 experts in our 24 offices around the world. Here you see that in yellow is where I'm based, together with Bongiwe and Kata, in the heart of Germany. And then we have regional offices, as well as country offices and a few project offices. We have an amazing network around the world, equally spread north, south, east, west. And those are the ones that we work with intensively, supporting them also to tackle climate change, not just looking at mitigation, but also adaptation and resilience. And I thought to bring the resilience component into this conversation. If we do not reduce emissions drastically, we are going to see much more of what you're seeing on the screen. Fires, floods, droughts, people in dire straits, and infrastructure destroyed. And we have to avoid that as far as we can and reduce the impact of climate change by avoiding, reducing, and offsetting emissions as well. So action is needed in so many spaces, and it relates to this conversation, not just looking at energy, but our building sector, our mobility sector, information, telecommunication, waste, you name it. That is happening at the local level in our cities, towns, and regions. And this is where we can track our emissions in a very effective way, but also taking responsibility. And who should do what? These conversations, that is what ICLEI builds capacity on, to help our local and regional governments understand where action should be taken, how to select priority investments, and making sure that they are transparent and tracking their emissions by conducting greenhouse gas emission inventory and by reporting, and if they can afford to do so, by verifying or using the validation system of ICLEI. And again, we're talking about territory. So you have a big city next to a small city, next to a rural area. These can collectively step up and work very effectively, also when we're talking about collective greenhouse gas inventories. Now, our Green Climate Cities program is ICLEI's offer of support to our local and regional governments in the ICLEI network. And this is a proven methodology useful for the global south and north, looking at governmental or own operations and budgets, but also specifically at the community-wide approach that can be taken. And we track progress of our network through CDP ICLEI Track, and we offer different services. And I wanted to zoom in on the services and specifically relevant to this particular conversation. Our Green Climate Cities program is a methodology looking at process. And the piece where you look at the yellow box part of the graph, analyze, that is where the greenhouse gas inventory comes in, where we help identify what data should be collected, help to identify how to deal with data gaps. And we have, of course, developed a global protocol with WRI and C40 called, in short, the GPC, the Global Protocol for Community Scale Greenhouse Gas Emissions, with a notation key system to help us understand how robust your data is. And again, that inventory informs your local decision makers and planners, your policy experts. And we have this whole approach is part of our commitment to the Race to Zero, which is a UN-led initiative globally, where our Green Climate Cities program is our support offer to help again on transparency and delivering of those wonderful commitments. A quick snapshot of our tool called ClearPath, which is a climate planner tool that supports inventory development, forecasting, planning, and monitoring, and is being used in the US. To show you an example of the kind of outputs that it generates, looking at residential energy, mobility, water, etc. A very helpful tool that also helps you track progress in a nice, powerful visual way that can inform your mayors and your councillors as well. And the forecasting is, of course, important. We need to know how to get on track towards climate neutrality. And we know globally we're not on track by any stretch of the imagination with the collected NDC targets of our national governments. So important to understand our emissions, important to work with the academic sector, with our researchers, and in particular with organizations and opportunities like Copernicus to understand how we can enhance and step up our collective activities in this case. Last piece I want to draw attention to is the science-based targets approach, which will help us step up setting more robust targets, but then also helping design how to achieve those targets, which leads to more efficient emissions reduction. Our CDP ICLEI Track is the reporting platform, our collaboration with CDP, and it serves so many initiatives. So it's a single reporting platform where you can report to the Global Covenant of Mayors, the Race to Resilience, the Race to Zero, and many, many other initiatives, including several ICLEI initiatives as well. So this is the go-to place that I wanted to share with you before I hand over to our next colleague, Richard Engelen. So let me stop sharing my screen here. And we will also make sure that these recordings are shared with you also at a later stage, so you can also reference, of course, our presentations, because you will get very dense and intense presentations today. So Richard, without much ado, handing over to you. If you could start sharing your screen, that would be wonderful. And then we can dig.
Thank you very much, Marijke. Let me start sharing. So also very warm welcome from me. My name is Richard Engelen. I work for ECMWF, the European Centre for Medium Range Weather Forecasts, which is an intergovernmental organization primarily responsible for weather forecasting, but we also now work within the Copernicus, the EU-funded Copernicus program on climate monitoring and atmosphere composition monitoring. Right, I hope you can see my slides correctly now. So I just have a few introductory words to let you know where this workshop fits. We are basically on a roadmap towards new elements within this EU Copernicus Earth observation program. So the whole idea of Copernicus is to monitor our Earth environment, atmosphere, land, ocean, all the elements with new satellites. This is a Sentinel satellite program, but also with additional service components. And the atmosphere monitoring service is one of those services and is now scheduled to implement new additional services on top of the current air quality services we already have to make sure we monitor.
Richard, sorry to interrupt.
Yes.
The way we're seeing the slides is in presenter mode. So we see the current slide as well as the next one.
Let's see if this is better.
Yes, now we see the full screen of one slide. Thank you so much.
Okay, apologies for that. Yes, we are on a roadmap towards additional services part of the Copernicus Atmosphere Monitoring Service. So the whole idea that is being implemented, which already started in 2015, is can we use Earth observation to monitor emissions at global scale, but also with sufficient detail that we can address the needs from the different requirements. So this is driven mostly by the European Commission and the European Union member states, but at the same time, we are also reaching out to other user communities around the globe to see how we can help local, regional, and national activities. So we're sort of halfway, well, a little bit further than halfway. COCO2 is one of the projects that's supporting this implementation of these new services in the program. And as part of COCO2, one of the things we want to do is connect to these different user communities. And therefore, we've worked together with ICLEI to reach out to city authorities, city regions to see how we can support. So why do we want to use Earth observation to help monitoring emissions? On the one hand, we have reported emissions, and if you look at national reporting, this is national total emissions every year. So you see on the left an example from the EDCAR database. So it is very accurate information, but there's not a lot of detail in there. While at the same time, with the new generation of satellite observations, we can actually look into very high detail already, look at cities, look at industrial areas. You can see an example here which shows NO2 concentrations, but resulting from emissions in the different areas in Europe in this case. So how do we combine the two elements to make better emission monitoring products? There are two main challenges we face by trying to do this. One is that satellites do not measure emissions directly. This is very important to be aware of. Satellites measure the impact of emissions on the atmosphere. The other thing is that satellites see only the total impact of both anthropogenic emissions and the natural processes. Of course, natural processes are also impacted by anthropogenic activities, by human activities. So there is a combination of this, but we see the result. So in order to translate what we see from the satellite, and here's an example, a simulated example of what the satellite would see on the left, to get to detailed emissions on the right, we bring in Earth system modeling. And we've been doing this for weather forecasting, but also for air quality forecasting and monitoring already for quite some years. And now we want to extend this to monitoring actual emissions of greenhouse gases and some other pollutants. So this brings us to the ambition we have to implement operationally in 2026, which is a greenhouse gas emissions monitoring capacity, which integrates the different elements of information we have. So observations from satellites, but also from ground-based observations, combine that with information we already have through other sources. And these are, for instance, reported emissions, but also statistical data. And you will hear a lot more about this later during this workshop. So we bring that in, combine this with our Earth system model, so we can simulate the atmosphere and how emissions are transported around the globe and match that with the observations we have to then provide added value products, both at global and at local scale. And this all in support of governments, policymakers, scientific community, industry, potentially the general public. But we need to see where we can really shake hands, where what we are developing can actually support, can help things that are already taking place, and then try to improve those. So this is why we have a strong user engagement program already running as part of the COCO2 projects, but this will continue in the coming years as well, reaching out to countries, reaching out through cities, reaching out to industry to really try to understand what are the needs and where can Copernicus potentially help. And my last slide is just to show already what we will hear later this afternoon, is what are the products we are developing. So by looking at an integrated approach where we bring in different information streams, not just the observations, there's different elements you can then use for different purposes. So yes, we will bring in inventory-based emission data at high spatial and temporal resolution. So we're working hard to use the national report emissions, but then add more spatial and temporal resolution based on all kinds of information. We bring in the satellite and the in situ data, which can be a product by themselves, but also support the added value products we will deliver. The added value data products, as I'm just saying, we will also bring in scientific evaluation of the estimates from different sources, and we also bring in the expertise to interpret the results. So by working together with the science community, with operational service providers, bringing all the information streams together, we really hope to provide a portfolio that can be useful for the policy sector at different scales. So this is the idea. We are working hard to implement this, but as we are doing this, we need to make sure we develop things that are fit for purpose, and that's why we are really interested in this workshop today. You will hear much more detail in the presentations that will be following, and hopefully during the discussion we can interact a little bit further. Thank you for this, and that's all for me for now.
Thank you so much, Richard, helping us understand what the COCO 2 project is all about. So now, without much ado, I'm absolutely delighted to have Rovana Bortolini with us from the city of Porto Alegre, a long-standing collaboration between the city and ICLEI. Rovana, we're so pleased to have you with us. The floor is yours.
Okay, thank you. It's a pleasure to be here to talk about the projects that Porto Alegre has developed in the climate agenda, and now I will share the screen and present in Portuguese. Okay. Are you seeing my screen, right?
Yes.
Okay. Então, Porto Alegre é a capital do estado do Rio Grande do Sul, fica bem no sul do Brasil. A cidade ela possui 13 parques urbanos, mais de 700 praças urbanizadas, o que significa que é uma cidade muito verde. Porto Alegre é referência, foi uma das primeiras secretarias do meio ambiente do Brasil, e agora, com a unificação do planejamento urbano ao meio ambiente, a gente tem conseguido desenvolver muitas pautas na pauta da sustentabilidade. O desafio climático ele é muito grande e se tornou urgente para a gente adaptar a cidade a um sistema de baixo carbono. Então, a gente tem implementado as nossas parcerias público-privadas através de fundos e capacitações técnicas com outros órgãos. Porto Alegre, então, está se preparando para essa virada. A gente tem a nossa lei municipal de sustentabilidade e mudanças climáticas, que através dela nos possibilitaram, então, desenvolver uma série de projetos. Estamos no processo de revisão do plano diretor e é a nossa grande oportunidade de inserir a agenda climática nesse regramento urbano. Todos os nossos projetos, eles são desenvolvidos a partir dos ODS, principalmente do 11 e do 13. E Porto Alegre tem se comprometido numa série de compromissos globais, sendo o marco a campanha Race to Zero, que nos comprometemos na COP26 a zerar as emissões até 2050. Então, todos os nossos esforços estão focados nessa meta. Então, como começo de tudo, nós fizemos o nosso inventário de gases de efeito estufa da cidade. Ele foi desenvolvido como um primeiro produto da revisão do plano diretor e, como resultado, então, Porto Alegre emite em torno de 2,5 milhões de toneladas de carbono. Nesse inventário foi demonstrado que houve uma redução das emissões nesse período em virtude do aumento do plantio. Então, o objetivo desse inventário foi identificar os principais setores emissores de gás carbônico em Porto Alegre e, através dele, elaborar as nossas políticas e projetos. Os setores contemplados foram energia estacionária, transporte, resíduos e agricultura e uso do solo, e o inventário demonstrou que o transporte é o principal emissor, com 67,7%, energia estacionária com 23% e resíduos com 8,8%. Em termos de transporte, 11% se refere ao transporte público, e em termos de resíduos, o nosso resíduo ele é enviado para outra cidade, onde ocorre a captura do metano, é por isso que o nosso valor é um pouco mais baixo do que outras cidades. Esses 8,8% se referem principalmente a tratamentos de esgoto ou esgoto a céu aberto. Então, a partir disso, a gente tem desenvolvido todos os nossos projetos focados nestes setores que mais emitem na cidade. Então, tendo como início o setor dos transportes, nosso primeiro projeto foi um decreto, onde a gente acabou com a obrigação de estacionamento nas edificações, porque o nosso plano diretor exigia um número mínimo de vagas nas edificações. Nessa figura aqui dá para ver o que o nosso plano diretor acabou criando na cidade, em termos de paisagem urbana e uso do solo. Com essa retirada dessa obrigatoriedade, a gente pretende incentivar o adensamento, a utilização da infraestrutura existente na cidade e desenvolver cidades mais caminháveis. O que tem acontecido é que, principalmente, as edificações para a baixa renda, elas acabaram sendo edificadas na periferia da cidade, justamente pela necessidade absurda de vagas de estacionamento, e o solo é muito caro nas áreas centrais. Então, com essa desobrigação, a gente pretendeu desenvolver melhor os modos alternativos de transporte, melhorar a densificação urbana, ativação das fachadas e, principalmente, o uso misto da terra, né? Com menos poluição, menos deslocamentos. Porto Alegre, esse aqui é o projeto Google Action Fund. Porto Alegre se submeteu ao edital do Google e 2 cidades do Brasil, então, receberam recurso para implementar projetos climáticos através de ONGs. Então, nós escolhemos 2 ONGs, que cada uma recebeu $133 mil para desenvolver projetos climáticos. Um deles foi desenvolvido pelo Centro Brasil no Clima, que ele fez um estudo para mensurar quanto custaria eletrificar toda a frota de ônibus de Porto Alegre e qual o seu resultado para a cidade. Então, aqui é uma tabelinha rápida que, se a gente colocasse todos os ônibus elétricos em 2023, a gente evitaria um custo de $744 milhões. Isso sem considerar os custos atrelados à saúde e às emissões de gases. Entrando agora no setor de energia estacionária, o projeto que participamos foi o Luz do Saber, onde nós recebemos uma capacitação técnica para um projeto de eficiência energética e geração distribuída em todas as escolas municipais da cidade. Com isso, a gente tem uma eficiência energética no momento que a gente troca os equipamentos que mais consomem dentro dessas escolas e faz um projeto de conforto térmico e uma redução do custo da energia, que foi estimado em $483 mil por ano, além de toda a questão da educação ambiental e redução das emissões. O outro projeto que recebemos através do Google Action Fund foi no Morro da Cruz Circular, que foi a instalação de painéis solares e biodigestores em 2 escolas e um centro cultural, numa área de grande vulnerabilidade aqui em Porto Alegre. E o biodigestor é um ótimo exemplo de economia circular. No momento que o resíduo da merenda ele entra no biodigestor, esse biodigestor gera um gás que volta para a cozinha, esquenta a merenda das crianças. E ainda como um subproduto, ele tem um fertilizante muito potente. Então, esse é um ótimo exemplo de educação ambiental nas escolas, eficiência energética, onde essas escolas já têm uma redução na sua conta de luz de 90%. Uma geração de energia alternativa através da produção do gás e menos poluição, e principalmente nessas comunidades tem muito foco de resíduo, então a gente diminui bastante a quantidade de resíduo gerado. Outro projeto se chama Rooftops Sustentáveis. Ele foi feito um decreto para possibilitar a implementação do uso das coberturas das edificações, desde que ela seja sustentável. Nosso plano diretor ele tem alguns regramentos e as construtoras acabavam utilizando toda a área permitida, todo o potencial combustível permitido para enfim, as edificações, para unidades para serem vendidas, e essa quinta fachada das edificações ela ficava então sem uso. Dessa forma a gente permitiu desde que seja sustentável, ou seja, tem que ter telhado verde, placas solares e acesso para todo o condomínio. Com isso, a gente tem como objetivo diminuir as ilhas de calor na cidade, melhorar o conforto térmico e diminuir também o escoamento pluvial direto para o sistema da cidade. Outro projeto que fizemos foi uma parceria público-privada para a troca de toda a iluminação pública da cidade. Era vapor de soja, então não estão sendo colocadas lâmpadas de LED. Com isso, a gente tem uma redução estimada em $2 milhões por ano, além da facilidade de instalação, maior durabilidade e menor emissão de gases de calor. Outro projeto que fizemos também, desenvolvemos através de um decreto, são os terrários urbanos. O que é o conceito de terrário? É quando a gente cria um microclima na cidade em pequenas áreas. Então, Porto Alegre tem muitas áreas municipais, a própria prefeitura, que elas não têm uso por serem muito pequenas, não têm potencial construtivo relevante para a venda. Então, elas se transformavam em focos de lixo e estacionamento irregular. Dessa forma, a gente criou um projeto onde a gente licita essas áreas para exploração comercial. Então, o arrematante dessa área, ele pode colocar um pequeno comércio, desde que ele cuide dessa área e transforme num espaço sustentável e de uso público por 10 anos. Além disso, o valor de outorga do vencedor, ele é transformado na compra de equipamentos para comunidades carentes, e nós estamos comprando biodigestores para colocar nas escolas. Então, como benefício, a gente tem uma melhor utilização dos espaços públicos, ativação da cidade, segurança nas ruas e a criação de espaços sustentáveis. Esse daqui é um exemplo do nosso projeto piloto, onde nessa foto mostra uma área de estacionamento irregular, era um terreno da prefeitura, e nós fizemos, então, um projeto, e quem ganhou foi uma empresa de açaí, que fez um projeto sustentável nessa região. Ele vai ser entregue semana que vem. Fizemos, então, a segunda licitação, que ganhou uma outra empresa de conveniência, numa outra nesga de um terreno da cidade, e esse terreno estava fechado, e assim a gente possibilita também uma ativação do espaço com um pequeno comércio. Esse aqui vai ser entregue no mês que vem. E devido ao sucesso do programa, nós agora estamos licitando a terceira área, uma área um pouco maior, e ela vai ter o foco na bicicleta, e em breve vamos fazer essa licitação. Esse projeto ganhou um prêmio do Ministério do Meio Ambiente aqui de Brasília, do país, tirou o primeiro lugar como inovação na gestão pública. Entrando no último setor, então, resíduos, nós fizemos um decreto para possibilitar a implementação de hortas urbanas comunitárias em parques e praças da cidade. Tinha uma demanda muito grande, principalmente nas áreas periféricas, para a utilização dessas áreas de parques e praças que não estavam urbanizadas. Então, assim, a gente permite o uso e a gente possibilita uma melhoria da alimentação da população nessas áreas através da alimentação orgânica e uma melhor utilização dos espaços públicos e a ativação desses espaços que estavam sem uso e sem urbanização. Com o projeto piloto do Google, que foi implementado pelo ICLEI aqui em Porto Alegre, nós, então, colocamos o biodigestor e levamos o prefeito para conhecer, que esse é um projeto muito legal mesmo, né? Um ótimo exemplo de economia circular. Ele adorou o projeto e pediu para a gente desenvolver para todas as escolas, então nós fizemos um termo de referência para a contratação desses biodigestores para todas as escolas municipais. Outro grande projeto que estamos desenvolvendo tem como objetivo a despoluição do arroio dilúvio. O arroio dilúvio é um arroio muito importante, que ele corta a cidade ao meio, entre norte e sul, e ele deságua no nosso lago Guaíba. Só que ele é extremamente poluído devido a uma série de condições, ocupação irregular, ligações irregulares de esgoto no sistema pluvial, e é um projeto muito caro, a prefeitura nunca conseguiu viabilizar, então nós achamos uma forma que seria a ideal, que é através de uma operação urbana consorciada, ou seja, a gente vai fazer uma regeneração urbana nesse setor da cidade, que é central, super conectado, e tem um potencial construtivo enorme, para que, então, o potencial construtivo adicional dessa área das edificações, ele seja vendido e revertido para a melhoria dessa área, ou seja, a despoluição do arroio dilúvio e a criação de um parque linear. Nessa imagem dá para ver que ele realmente corta a cidade de deságua no nosso Guaíba. Então, nós fizemos um projeto conceitual, que é o que a gente espera para essa área, uma renovação urbana, maiores edificações, adensamento, e um parque urbano que se conecta ao Lago Guaíba, onde já existe toda uma orla urbanizada. Então, nós desenvolvemos o que a gente realmente espera dessa área, e fizemos um termo de referência, e agora ele foi licitado para a contratação de uma consultoria especializada, que vai fazer todos esses estudos da área, transformar numa área de baixa emissão, com muita arborização e, enfim, um espaço muito mais sustentável, e além disso vai propor um anteprojeto para a gente executar depois. E agora, englobando todos esses setores, nós fizemos, através de um decreto, nosso programa de certificação sustentável, onde a gente premia as edificações que adotam premissas de sustentabilidade. A gente incentiva essa premiação, né, na verdade, através de incentivos urbanos e fiscais. As edificações, elas têm que demonstrar o atendimento de, no mínimo, alguns itens nessas dimensões, são 7 dimensões. Cada selo está linkado à quantidade de itens. Então, para tu obter o selo diamante, por exemplo, tem que ter a pontuação mínima em 5 das 7 dimensões. De acordo com cada selo, tu vai ter um incentivo. Por exemplo, para as edificações que estão em construção, a gente dá um incentivo urbanístico. Com o selo diamante, por exemplo, o empreendedor consegue 20% de aumento na altura, além do que o plano diretor já permite. E como incentivo fiscal, a gente está propondo o desconto no IPTU, que é o Imposto Predial Territorial da cidade, ele, com a certificação de diamante, por exemplo, o residente vai conseguir 10% de desconto no IPTU, válido por 3 anos. Foi aprovada a lei na Câmara agora, estamos em vias de sancionar ela pelo prefeito, para começar a valer em 2024. E, fazendo o fechamento, então, geral, após toda essa nossa caminhada, a gente está elaborando o nosso plano de ação climática. Conseguimos recurso a fundo perdido através do City Gap Fund, implementado pelo Banco Mundial. E o Banco Mundial contratou uma consultoria para implementar nosso plano de ação climática. Então, o objetivo dele é fazer um estudo de vulnerabilidade para verificar como é que está a cidade em termos de preparação dos efeitos adversos do clima, e então propor uma série de medidas de redução de gás carbônico, mitigação e adaptação desse território às mudanças climáticas. Nosso grande objetivo depois disso tudo é desenvolver um programa de monitoramento dessas ações e dos seus impactos na cidade. A gente já tem elaborado uma série de projetos e com o plano de ação climática teremos outros a serem alcançados e, enfim, conseguir a nossa meta de redução e zerar as emissões até 2050. Muito obrigada.
Wonderful. Thank you so much. It's excellent to see all the actions Porto Alegre is taking, especially also understanding where your emissions come from and then designing actions that are really tailor-made. I had hoped to see a bit more on where you're getting your data and so on, but we can discuss that a little bit later, Rovana. But thank you so much. This was very inspiring. And I think it's also important that our academic and research colleagues understand what a city really does with a greenhouse gas inventory. So super exciting. And again, glad to see you're committed to the race to zero, and we want to step up our support as ICLEI also to you. And maybe that could also be an interesting conversation piece later on in the discussions. So without much ado, let's hand over to Dr. Frédéric Chevalier. You are going to tell us more about the use of satellites at city scale. So over to you, Frédéric.
Thank you very much. You can hear me well?
Perfect.
Thank you very much, Maike, for this very warm welcome. I'm very glad to be here because everything that we are doing here is user-driven, and for us it's particularly important from time to time to keep touch, to touch base with you, potential users of what we are doing, because that's our goal, to serve your needs. So in this presentation, it's a bit like the other end of the spectrum compared to the previous presentation. I will not show any building. I will not show any street. I will show the globe. I will show large regions seen from space. I will discuss the current snapshot of where we are to serve your needs at city scale. I will show that it's complicated, it's challenging, but we are far from the start. But we still have a lot of milestones to achieve before we can really have the best products for you. It's challenging because, as Richard explained a bit earlier, we do not see the emissions of greenhouse gases from space. Indeed, an emission, it's a rate, the number of particles per unit of time and unit of area, and this is not visible directly from space. However, from space, we clearly see, I will show several examples in the next slides, we clearly see the emission plume, so the particles after they have been emitted. So this is simply sketched here. If you are able to count the number of molecules outside of the emission plume, so in the background, if you are able to count the number of molecules within the plume, and if you have some knowledge about the wind direction and wind speed, then you can have a good estimate of the emission of this facility, for instance, but it could also be a whole city. So I'm talking about mostly CO2 here. I will briefly discuss methane. I'm mentioning CO2 because that's the toughest. That's the toughest because CO2, as we know, accumulates in the atmosphere, and that's why it presents a very strong climate threat, because every year we pile up the emissions of the current year, on top of all the emissions of the past. There is a bonus, a discount from Mother Nature in the ocean and in the terrestrial atmosphere, the terrestrial biosphere. However, we have this onward trend, positive trend of carbon dioxide due to human activity. And so the variations of carbon dioxide in the atmosphere are particularly small compared to the background level. So we are talking about variations of carbon dioxide concentrations of the order of the percent, only 1%, about a few percent maximum. To monitor these variations, we need to have an exceptional accuracy compared to these variations. So let's say that the random errors that we can tolerate to monitor these variations, let's say that they should be not larger than 1/4 of the variation, so 0.25%, 1/4 of a percent. And in terms of systematic errors, the fact that you are always on the same way of the error, on the same side of the error, always positive, always negative, we can't tolerate more than about 1 per mil, so 10 times less than the variations. And in addition, we need to have information, we need to see the carbon dioxide in the lowest layers of the atmosphere. That's particularly important because that's where the emissions occur, those that we are interested in. Of course, there are, for instance, airplanes above, but most of the fossil fuel emissions, they happen in the boundary layer, so very close to the surface. And for that, technologically speaking, we need to use reflected sunlight, at least currently, and we are restricted to clear sky and daytime. So those are limitations that we need to address, and I will mention that several times in the following slides. With these specifications, so 1/4 of a percent for random errors, 1/10 of a percent for systematic errors, we are really pushing the limit of remote sensing from satellite in general. We are pushing the limit. The best satellite instruments that monitor carbon dioxide today use detectors that were designed for the army. I mean, for other purposes than carbon dioxide, but just to give you an idea of what we are doing here, it's not just basic material available from the shelf. The first carbon dioxide dedicated satellite was launched in 2009 only, so that's quite recent compared to other molecules that have been monitored for more than that. That was a satellite launched by Japan. So this is all for carbon dioxide. For methane, the situation is quite similar, but slightly less challenging because the variability, the relative variability of methane in the atmosphere is smaller than for CO2. So when I'm talking about carbon dioxide, I'm talking about the toughest. So carbon dioxide, methane, but here I'm presenting what we would like to do. And I'm referring to a pollutant, so it's not a greenhouse gas, it's nitrogen dioxide. Richard Engelen showed one slide about this pollutant. It gives us a vision to materialize what we want to do with carbon dioxide. Here we have an instrument from ESA that has been flown since 2017. It's a satellite called the Sentinel-5 precursor, and it's an instrument on board this satellite called TROPOMI. It has a very large swath, so it looks a lot on the side and not just below the instrument. And from side to side, you have a swath of 2,600 kilometers. The resolution is of something like 20 square kilometers currently. And with this instrument, we see the column of nitrogen dioxide. On the left, you have an image that accumulated all the observations of the column of nitrogen dioxide seen by the instrument during last August, or August 2022. So no surprise, you see some large cities. I mean, I have here zoomed over France, but we have the same for the rest of the globe, obviously. So here you have Paris, close to where I'm sitting now. You have London, several cities in Germany, Italy, for instance, Milan. Interestingly, here it's not a city. Those are fires in August, where we have strong fires in the southwest of France. So this is what we see from the satellite, not directly actually, because the satellite measures radiation, but you can translate this radiation measurement into a number of NO2 molecules, thanks to additional information, auxiliary information, about the state of the atmosphere and the state of the surface. Once you have this, you can try to deduce with other auxiliary information, in particular, mostly wind information, but also information about the atmospheric chemistry. You can translate this information about the NO2 molecules in the atmosphere into an emission rate of nitrogen dioxides with the plural, so it's not just NO2, but also NO. So no surprise, we recognize the same patterns that on the left, but this time the unit is a unit of emissions, number of molecules per unit area and unit of time. But the information is broadly the same. You see that the figure is, I would say, quite noisy. It's not smooth. You also see large variations over the ocean that relates to the uncertainty that we have in these emissions. It's not a perfect estimate. We have an error bar, but we definitely have some information, interesting information about the European cities. So that's for a pollutant, NO2, which is challenging to measure, but currently we know how to do it with a good accuracy. For CO2, where are we? We have here the example of, I would say, the best instrument that we have up in the air, in space, to monitor carbon dioxide. It's an instrument that has been, I have one slide too fast. It's an instrument that has been flown by NASA since 2014. It's in polar orbit like the previous one, so it goes from one pole to the next. But this time, you immediately see on this figure that it has a very narrow swath. So it's a tiny strip below the satellite track. Maximum from side to side, you have 10 kilometers. Compared to the previous one at 2,600 kilometers. And the ground resolution this time is thinner, so we have more fine detail along this tiny strip. It's 3 square kilometers. We look at the column average of carbon dioxide that can be recovered from the satellite measurements, provided we add some additional information that's here, about the state of the atmosphere and the state of the surface. And here on this figure, you have one orbit of an CO2 track on the 16th of November 2022. So that was a few months ago. We are in the early afternoon, so it's an instantaneous orbit. And here you see reddish colors east of the city of Ningdong in China, so that's roughly the middle of China. And these patterns are actually aligned with respect to the city and some industrial facilities, and in particular coal power plants. There is one here, for instance, but there are also at least one in Ningdong itself. They are aligned with the wind direction. So we clearly see emission patterns, even though we have a tiny band of data. With this data, with this column of carbon dioxide and knowing the wind direction, we are able to estimate the emission rate of carbon dioxide in the city and in the power plants, the coal power plants that surround the city. I'm not giving numbers here. I will come to that in a couple of slides. So here it's the best instrument that we have up in the air. And you see that, well, we are not at the level of monitoring like we have for pollution. NASA has a second instrument, which is actually called OCO3, because there was an OCO1 that failed. But OCO3 is not on its own satellite, it's on board the space station. It has been there since 2019. It has the same characteristics than OCO2 in terms of technology, but there is a mechanism that allows to monitor the same scene several times consecutively. So if you add all the bands together, you can have an image like this one. This one is an orbit track, so OCO3 on board the International Space Station. We are above the city of Baotou in China on the 21st of October, 2022. We are again in the early afternoon. And well, you can guess the city here below the colors of the CO2 column. The city is there, and you clearly see here the plume of carbon dioxide over the city, and also its coal power plants. You have the wind arrow here that corresponds well to the direction of the plume given the location of the city. So with this, sorry, I'm just trying to play with the extra windows. Yeah. So with the archive of OCO2 and OCO3, so starting in 2014, we have a long-term monitoring of cities and industrial facilities. We estimate emissions with this archive. We quality control the results, and we also disaggregate the results because sometimes the same plume can be attributed to several objects, maybe one city, but also the coal power plants or coal power plants nearby. In particular, we have identified 49 individual cases of coal-fired power plants in the USA in the OCO archive, so OCO2 and OCO3 after quality control. So 49 cases, it's not a lot. So you can monitor, you can see one power plant several times. So in total, 49 is not a lot, but we have a stringent quality control. And remember that with OCO2, that provides most of the data, we only have a tiny strip of measurements. If we compare the numbers that we estimate to the numbers reported by the US Environmental Protection Agency, we get the following figure. On the vertical axis, you have the EPA number for the emission, and on the horizontal axis, you have the number that we estimate from the OCO2 measurement and OCO3. We get a fair alignment along the one-to-one line. In terms of statistics, the spread is of 54% and the bias is at 1%. So to make it simple, it's a large spread, but it's random, but we have a small bias. So that's the current situation with the current instruments that are flying up in the air. In 2026, as Richard explained, we will have a boost, in particular with the space component that will be equipped with the CO2M constellation. So let's imagine the width of Tropomi, so 2,500 kilometers or so, with an instrument that looks at carbon dioxide with roughly the same quality like OCO2 and OCO3, to make it simple. So that's what we should have in 2026. And it will not just be one instrument, but it will be several instruments. So you will have a frequent revisit of, in particular, the cities. An example of orbit as simulated is shown here on the top right. So you can here clearly see the impact of the width of the orbit. This is a map for convenience. It's about the western part of Europe, well, France, Germany, the Netherlands, some of the UK, etc. Some of Italy, Switzerland. You can recognize all these countries, and this is here the track as it had been simulated. And on these two stamps here, the two maps, you can see what we expect currently with our simulations, what we expect in terms of uncertainty reduction compared to the existing. So you have inventories on the ground. How much can we reduce the uncertainty of this inventory for that particular orbit track and the emissions that are around it? So you see that below the orbit track for the large industrial power plants, so that's the figure on the left, and here for the rest of the fossil fuel emissions, so that's the figure on the right, you have an uncertainty reduction in percentage that can reach up to 50% for some facilities. So that's around Essen in Germany. But you also have, for the other fossil fuel emissions in Germany in particular, reasonable uncertainty reductions, 20, 30% for some districts. So we have here gathered the information by administrative district. So that's what we expect, and that's just for one orbit track. With CO2M, we will have a lot of orbit tracks, and we will have several satellites, hopefully 2, 3. The final number has not been decided yet. This satellite information will be inserted into a much larger system, which is sketched here. It might be a bit fuzzy, but the idea is basically to bring all together all the observations. That's also related to one of the slides of Richard. All the observations will be brought together, and also different types of models, so that we can cover the whole globe, but also the regions with the best accuracy given what we are trying to achieve. So to summarize this presentation, COCO2 so far has put the priority on carbon dioxide emissions rather than methane. That was a choice initially, but it's also the toughest problem. And on the site, well, within COCO2, but also outside, we have been able to address methane and have quite exciting results, in particular for leaks of methane. But just remember that what I've shown here, that's the toughest. And for the toughest, we have exceeded expectations for the estimation of CO2 fossil fuel emissions, exceeding expectations, in particular because the instruments that we are currently using, or CO2 or CO3, they were not designed for that purpose. They were designed for other things, in particular the natural biosphere. For CO2M, that has been designed for the monitoring of fossil fuel emissions, we expect a lot. We see that we currently have, with the existing instruments, a large random noise, but a low bias, which means that already we can compute robustly trends if we average over large amounts of data. But for the near future, with CO2M, we will definitely have the orders of magnitude of additional data that we need to have robust statistics. With CO2M, we therefore expect a low random noise for the emission estimates and a low bias. Still, there are limitations. We are limited by the capacity to retrieve carbon dioxide in clear skies, but that's also the case for methane, also for some pollutants. Clear skies during daytime only. We also have different difficulties. Some emission plumes from different emitters, they overlap. Sometimes we have very complicated wind patterns, etc. In particular, during the COVID, we were very interested in the decrease of the CO2 emissions in Wuhan in China or the eastern part of the US when the first confinement occurred. And bad luck, at those times, we had strong clouds above the interesting areas, and we were not able to directly see the reduction of the fossil fuel emissions there. So there are limits, and I would not like to hide them, but still we have strong hopes. But given the limits that we have, we want to complete the information that we have from space with other types of data. And that's the reason why we have these other presentations that are an integral part of the future vision of this integrated system, So there is one presentation about ICO-cities with other types of measurements, and another presentation about high-resolution inventories using satellite data, but also other types of data. Thank you very much.
Thank you so much, Frédéric. That was very, very informative. And I think we don't have much time for questions. So if anybody has a question, please put it in the Q&A as text, and then Frédéric can answer. I see there is already a question for you, Frédéric, so please go ahead and answer. And then let's go over to Dr. Lucas Emmeninger on the ICO-cities piece, because I think this is a lovely logical segue into your presentation, Lucas, as you pull it up. So the ICO-cities evaluation evaluates measurement approaches for the observation of greenhouse gas emissions in densely populated urban areas. So that's exactly what we're looking for to better understand what opportunities we have from the ICO-cities approach. Over to you. The floor is yours, Lucas.
Thank you, Marieke, for the introduction, and hello, everyone. You should be able to see my slides and hear me. Is that correct? Good. Yes. So I'm very happy to talk about ICO-cities on behalf of the consortium. ICO-cities, which is a project towards integrated city observatories for greenhouse gases. There are lots of people contributing, and only some of them are here on the authors list. So let me just stress that I'm just the one presenting, but it's certainly not my work. The ICO-City project essentially intends to bring together and evaluate measurements and modeling approaches to monitor greenhouse gas emissions in densely populated, that is to say, in urban areas. And we do this by developing tools and services for cities in support of their assessment of emission reduction efforts. ICO-Cities is a project that started in 2021. It will last for 4 years. It will end in 2025. It has about 30 million euro funding. It includes 30 scientific partners from about 15 countries and 15 partner cities. So it's a large consortium with lots of partners, and we really want to bridge this between the scientists and the city and the semi-administrations. 3 cities are more important than the others, or I may say more equal than the others. Those are the 3 pilot cities. In the 3 pilot cities, which are Paris, Munich, and Zurich, we combine all the measurements tools, all the knowledge, all the infrastructures to do experiments, to evaluate methods, to then define what the best methods are for individual cities or for certain circumstances. It's a lot about observation and modeling, and I will start with the observation strategies. We already heard a lot about satellites, and there are other ways to observe carbon dioxide and other greenhouse gases. One option is to have high precision measurements on tall towers, that have a footprint, observe quite a lot of the city emissions. You can go closer to the emissions, closer to the sources, and do roof level or street level networks with sensors, for example, for CO2. Then there's the option of having ground-based observations, ground-based instruments that look, for example, at the sun and thus measure the total column of, for example, CO2, the total or average concentration between the ground and the sun, if you want to say so. One of the very special technologies that we have available is eddy covariance. Eddy covariance is the only of the techniques that I'm showing here that actually directly measures emissions and not only concentrations, as Frédéric very well pointed out. Most of the time, we determine concentrations and then have to derive emissions from these. It's very important to realize that CO2 is strongly impacted by biogenic processes. So the biology is both the source and the sink, and if you want to understand what's happening also in an urban area, we have to measure these processes. And we need to know what wind and other meteorological parameters do in order to derive adequate models. And last but not least, I'll come back I come back here to the satellite observations, which are not part of ICOCITIES, but we do use satellite products within our project. I'm a representative of the city of Zurich, and much of what I will say is true for the city of Zurich, but also true for other cities conceptually, obviously. Why the city of Zurich was the first one with within ICOCITIES that started with the measurements, with the measurement campaigns that we have in our project. It's a small city. The center here is what we're essentially looking at. So a radius of about 5 kilometers, and you see it's between hills, and it has some sort of a tunnel here going to the other part of the city. So it's a relatively complicated system. This was also one of the ideas within ICOCITIES. They did not only want to look at cities in flat terrain, such as Paris and Munich, but Zurich within this somewhat typical system in Europe with hills is also one of the targets. Zurich has quite a lot of observation technologies. So we have high precision measurements in the background. We have 20 systems measuring CO2 on the rooftops. We have about 60 low precision or low cost street level measurements stations. We have 1 tall tower for anti-covariance, and we have 2 wind lidars to get wind information. So this is just one of the concepts. The idea is not that every city should copy everything, but the idea is to compare those methods and come up with solutions of what is best under what circumstances. Paris has even more. Paris has a larger system, and I just highlight in red the 2 technologies that Paris has in addition. It has FTIR column measurements, and it has LiDAR oscillometers that give us information essentially on the atmospheric structure, aerosols, and clouds. Munich is also, again, very similar in technologies. What is quite special in Munich is that they have a long history of total column FTIR measurements that I will come back to later on. Now, I'd like to make this a little more tangible. Otherwise, it's just dots on maps that look nice and colorful. If we go to this mid and low cost sensors, this is an example of a low-cost sensor. It's a battery-powered system that you can put up on a lamp pole. It measures automatically for years, it transmits the data. So that's what we would like to have as a sensor. The perfect sensor that is easy to run and is cheap. Unfortunately, such sensors do have drawback. They're usually not precise and reliable enough. So running a low-cost sensor network is very tedious, and very often it will not lead to the right quality of data. And I also tend to say low-cost sensors sometimes lead to very high-cost networks because of the work you have to put in to make data valuable. A compromise between the very high cost and the low cost is maybe what we call the mid-cost sensors. These are a couple €1,000. A sensing unit is in the middle, which is quite small. It even has calibration gases. You can put it up on the roof or in the building, and with a tube sample from the top of this antenna, for example, you see here the sample inlet. This is something that can be done that is quite efficient and may actually be a very good compromise between, let's say, a satellite and a low-cost sensor. I'd like to stress that if you want to put up such a sensor network, having access to the roofs, having access to the building is actually one of the challenges. And it's important that here we collaborate with the telecom provider, Swisscom, that gives us access to all of their antennas in the city. We also need to look at biogenic activity that can happen from satellites, as we heard before, but we also need very local information. And here you see just one example. On an individual tree, we actually measure the growth rate of that tree to have a good idea of what biological processes do in the city trees. And again, I would like to stress, to do this, it's not only necessary to have instruments, you need access to the trees, to the parks, and collaboration with the administration. In our case, with the City Parks Administration is key. We already talked about emission inventories. Zurich has a very detailed emission inventory with about 20,000 point sources for all the greenhouse gases and air quality measures and air quality substances. And that's very important to then derive good models and combine the models with the observations. And again, collaboration with the city administration really helps to have reliable data. Once you know what these inventories are, once you have somewhat an idea of what the emissions are, then it's very good if you can combine that with simulations. In a city that can be at different scales, ideally, and that's just one example here, at very high resolution, at building resolved scale, with a system such as GRAL as a modeling system here as an example. Depending on the city you're looking at, depending on the size, Zurich is a very small city. And again, collaboration is very important because one of the input data you need is actually city maps, or ideally some sort of a digital twin of the city to allow to set up a model at high resolution, because you need to know where the buildings are and what they look like. We also set up one high tower or one measurement point at a tall building in the city of Zurich. You see that at the left. Here on top of this high-rise building in the city, we have an antenna which is owned by the city police. On top of this antenna, we were able to install instruments and sample ports. This is an eddy covariance system measuring directly CO2 emissions. And you see 4 actually inlets that will also be used to draw the gas for other analyzers to get additional information. Again, this is only possible through the collaboration with the city police, which gave us access to the antenna, and through the buildings administration, which gave us access to the building and to rooms inside the building to actually set up additional instruments. Once we had that, it's actually a beautiful observation point. If you look at the footprint at the left, the footprint is somewhat the source sensitivity of our measurement point. So we observe in the middle and we get information about what you can easily observe is a very large part of the city, and it's probably quite representative. So from this single point, we probably get representative data for much of the city, which we can then combine, for example, with inventories. And I'd like to highlight some of the very first data that we have here. So you see that in the summer, in July, CO2 total flux out of the city is lower. That has to do with biogenic activity, mainly photosynthesis, contributing in a negative way to the CO2 emissions of the city. Whereas in winter, we have no photosynthesis, but we have higher fossil fuel emissions because of heating. So in the winter, the CO2 net flux that we observe out of the city is higher. I would like to come back to the technique I mentioned before. If my slides advance, now they do. In Munich, we have this beautiful column network with 5 FTIRs looking at the sun and measuring the total average concentration in the atmosphere. And you can easily imagine if you combine such total column information with additional information and wind information, then you can derive directly CO2 flux out of the city. That's the idea with this network here, and we're very much looking forward to results in terms of the net flux out of the city. And I would like to stop with an example from Paris, which is an outstanding example. Paris has quite a long history of high precision measurements in a network that you can see here with these dots, that 6 or 7 dots that actually represent high precision measurements in the city. That's one part. The other part is inventory-based emissions estimates for the city over many years. You see the decrease here, and you actually see 2020, the COVID reduction in fossil fuel consumption, and thus fossil fuel based CO2 emissions. And what is very novel and very interesting here is based on the measurements and inverse modeling. You see these blue boxes here that are an observation-based estimation of the city's CO2 emission, which agrees very well with the inventories that we have. So that's really what we'd like to see. We would like to see inventories that are reliable and representative, and observations that are additional information confirming or maybe at some point disagreeing with the inventories, and bringing all of that together to gain real confidence in the city emissions estimates. So in short, ICOS evaluates many observation based methods in the cities of Paris, Munich, and Zurich. We also extrapolate on novel and complementary technologies that I did not talk much about now because of the sake of time, in order to create a blueprint for independent urban monitoring attribution of greenhouse gas emission reduction efforts. And the best and most cost-efficient strategies will likely depend on local parameters, and I stress this again, also on local support and collaboration. And with this, I would like to thank you for your attention, and I'm happy to take questions if we have time.
Thank you so much, Lucas. We do indeed have a bit of time, so just checking if anybody has a question, feel free to raise your hand. I'll just see if I can spot anybody in that sense. But a lovely, very interesting presentation so far. A lot to digest actually as well. So I think it's interesting to see the approach and the technologies being used. So thank you so much to all our speakers so far, Lucas, Frederic, Rovana, and Richard. I do not see any raised hands. Are there any questions coming also from our expert panel at this stage? And if not, we can go into a short break. Nope. Okay. Well, Lucas will definitely. Yes.
There's,
go ahead.
there are two hands.
Okay.
Yeah.
Over to you, Kata, then to introduce.
Yes. So I just yeah. Go ahead. You can ask the question. I muted you.
Yeah. Can you hear?
Yes. Perfect.
Yeah. I have a question about using satellite data for estimating urban emissions, and seems like satellite can be used to estimate scope 1 fossil fuel CO2 emissions, while inventory is based on the consumption or activity base. So it includes scope 2 and scope 3. So have you thought about sort of like aligning that sector mismatch between inventory versus observations?
Is the question for Richard?
You can field that question for us.
It's a question for everyone. It's like it's from both sides, like a satellite and also inventory. So there has to be some compromise between two approaches, and I wonder whether you guys have been discussing about that from two different approaches.
I can maybe start, and Frederic can add if he likes. So yes, this certainly has been discussed actually in more than one way, because this applies to other sectors as well. Frederic is very knowledgeable on looking also at the FOLU more on a national scale, agriculture, forestry, where also again, in order to compare apples with apples, you need to make sure you make corrections where needed and look at the same thing. So the same applies to cities, where indeed with scope 1 and 2. So this probably needs further discussion to see how we best make sure that we compare the same things. I would actually say at the same time that using the observations and look at an urban area as a whole has its own added value as well, because you really see the impact of all these things together on the atmosphere. What's in the end is what matters. And Lucas, for instance, showed the impact of the biosphere over Zurich, that has an impact on the total emission of an urban area. But if you want to go into more detail and then compare against the fossil fuel emissions from a city and how this is calculated with what we derive from satellite observations, then we need to be very careful that we compare indeed the same thing. I don't know, Frederic, if you want to add.
Yeah, I mean, the difficulty, of course, is that a molecule emitted from one sector has the same impact on the total column than a molecule emitted by another sector. So to distinguish between sectors, we need to add extra information so that we can partition the column or the emission that we retrieve. Sometimes it's easy. Richard mentioned AFOLU, because the parcels are different. For a city where everything is a bit entangled, at least a lot of the emissions are entangled, it's more complicated. So yes, I mean, for the vision that we have with everything together in the same system, yes, we will definitely have sectorized information. With just the satellites, I don't think we can have this level of detail.
Maybe I can add to this. We discussed this also with the city quite intensively, and their approach is very clearly that in terms of atmospheric based observations, if that's what we call observations, it's really what we talk about is the direct emissions of the city, hopefully also with sector-wise information. And that does not include all the indirect, all the imported, all the other things. One of the important arguments there is also if every city does this, then you will at the long term also reduce the indirect emissions. So in terms of being somewhat self-centric is not giving the whole picture, but if everyone does this, then it will help the whole picture too.
There's actually another question, which is maybe also linked to this conversation, looking at the air quality angle, whether there's any satellite tracking black carbon, particulate matter. I'm not sure if the satellite tracking is actually the best way to deal with that, but that's an important question as well, since air quality and looking at that in our city centers, which are typically really struggling to get on top of that piece. So anybody who can respond on the black carbon question? You're muted, Frédéric, if you wanted to speak.
Yes, okay, the button is a bit hard. Yes, for black carbon, we do have satellites that monitor aerosols in the atmosphere. So we see black carbon from space. Transforming this information about black carbon in the atmosphere into emissions. Compared to carbon dioxide or even methane, there is an additional complexity because the chemistry is a bit challenging. I mean, it happens more in the atmosphere than for just CO2, which is a boring molecule. Once it's emitted and goes up, it stays there. So there is more work to be done there, but we can also address black carbon.
Okay, I actually can confirm I have black carbon on my windowsill because we're right next to the Rhine and the diesel ships are severely polluting my direct environment. On that high note, I would like to invite everybody to take a brief break that we convene in 10 minutes time. Take the time to reflect on all the interesting stuff you've heard. Stretch a bit, refresh your water jug or your coffee and tea mug and join us in 10 minutes. That would be roughly 5 minutes past 3 p.m. Central European Summertime. Looking forward to the next conversations. We will have 2 more presentations and then we'll have a wonderful discussion also with all of you. So collect your questions in the meantime. See you in 10 minutes. Thank you.
Thank you, Maaike.
Hi, Philippe.
Hello. Can you see my screen?
Yes, I can. Let's give people maybe another minute or so to join. And then I will introduce you. Okay, colleagues, I hope you have rejoined us. A warm welcome to the second part of our workshop today. And we will continue to dig in, this time looking at high resolution emission inventories in near real time for cities with our dear colleague, Dr. Philippe Schaars, joining us as a researcher from LSCE. So Philippe, the floor is yours.
Thank you very much, Marike, for the invitation. So I'll try to present some of our latest results dealing with the provision of high-resolution, low-latency inventories for cities, mainly for CO2 emissions. Users of those data are, of course, operational centers and researchers involved in simulating the atmospheric composition, but not only, also city stakeholders themselves and different governments with whom we are working. This began during the COVID as an international initiative involving the University of Tsinghua, our laboratory, and the University of Irvine. Emissions were changing because of the strong disturbance of human activity, but we did not know by how much, when, and where. And we realized that the existing inventories at national scale are lagging behind time. And they are only annual data. They don't produce short-term estimates of the variations. Annex 1 countries update their inventory with a lag of 2 years. Non-Annex 1 countries, some of them have not produced a new inventory since 10 years. And as we know for cities, many cities do an effort to produce inventories, but very few of those inventories are more recent than 1 or 2 years in the past. So our approach consists in collecting a lot of data which are not directly linked to emissions, such as fuel, because we cannot collect those data in real time, but we collect activity data that are strongly related to emissions. For instance, we collect every day power production data from 130 countries at utility level or at national level from different sources, including in China, India, but also now in Mexico, Turkey, Brazil, Chile, and South Africa, also countries from the Grand South. We use mobility data from Baidu, from cell phone geolocation indexes, from TomTom for more than 500 cities in the world. And we also have the position and the type of different aircraft and ships out of which we compute emissions. So this is a glimpse at the type of activity data we are collecting. They're, of course, different in quality and quantity in different countries. Insofar, our ground transportation data are based on congestion indexes that we transform into emissions using relatively simple parametric models, but we now move to more spatially explicit data. One of the big blind spots is the residential sector, because houses use fuels, but sometimes they store petroleum or wood or coal, and we don't know how much. So in some countries, like in Europe, where natural gas is the dominant source of heating fuel, we collect daily data from pipeline infrastructure. We fix the issue of storage. We allocate the gas use into different sectors to end up understanding how much natural gas is used by each region of Europe every day. And in the United States, we even have a similar data set based on more than 70 different pipelines for 3,000 counties of the entire US. on a daily basis. This is big data. The scrapping or the interrogation of website is automatized. We have an automatic processing code. We collect about 30,000 data per day. Insofar, more than 50 million data, raw data have been collected. There is a pre-processing module, which is automatized, and then we filter outliers. We do some manual check, and we transform those activity data into emissions for the power sector here. It's relatively simple. We know the power produced by each type of power plant. Each of them have an average emission factor. And this is how we can end up, for instance, producing on the right for the EU and the UK daily emission estimates that started since 2019, and they are updated until the end of April 2023. The data have been published in a number of articles, more than 30, including in Nature Communication, Nature Climate Change. It's a large group of students and researchers, which is now supported in Europe through the Copernicus CAMS service. All the data are publicly available. You can log on the website and find data. We have different products. We have global, national, daily CO2 emissions for 6 sectors, 36 countries and rest of the world. We have emission estimates for all the provinces in China, states in the US, and we now have power data, not emissions, but raw power data for different type of power productions, including more than 130 countries. Here, I will mainly talk about 2 recent products which are relevant for urban areas. One is a global gridded map of CO2 emissions, which includes cities, and near real-time CO2 emissions for more than 1,300 cities in the world. So once we have daily national emission, of course, the challenge is how can we do city-scale estimate? I don't think I need to explain in a long time that the current kind of Excel-based reporting of cities is not adequate for targeting decarbonization policy. First of all, because of this lag problem. Secondly, few inventories are spatially explicit. In the city of Zurich and Paris, yes, but not in other cities that have fast urbanization rates. So there is no mapping and targeting in a kind of GIS way, so that city planners can target the most cost-effective measures. And I would add that there is also no good matching between the current inventories and the MRV that are required for carbon credits. And as a result, there are thousands of projects for forest. And even though cities are representing more than 70% of global CO2 emissions, there are very few urban decarbonization projects based on carbon finance. So our data has been first downscaled from nations to 10-kilometer grid. How do we do that? Well, we know the spatial activity patterns from the largest point sources using a large database called GID. We collaborate with our colleagues from EDGAR to use their spatial patterns of activity. And then we blend this with the satellite tropome, not tropopy, NO2 satellite data to infer changes in time. For instance, during the confinement in China, the province of Wuhan, Hubei, was more affected than the maritime province, but in 2022, it was the reverse. So the EDGAR activity are spatially static. So we give them some kind of temporal variations using the pattern of NO2 concentration. Now we have a daily map over the entire globe of CO2 emissions for 6 sectors. And we sample the map over city areas, and then we make a comparison with available inventories. One issue is, what is a city? Sometimes a city is an administrative boundary. Sometimes it's defined by land cover, and sometimes it's defined by a kind of socioeconomic dimension of people who live as urban people. So we provide our estimate sample from the map for, as I said, I think it's 1,500 cities. All the data are publicly available on 2 geographies. One of them is the administrative boundary. The other is the so-called FUA, functional urban areas, that have been provided by GRC. it makes a lot of difference whether you talk about the San Francisco city or the entire Bay Area or the Paris mega city with all the satellite towns and the downtown Paris. Of course, the emissions are different. Yet we see that there are very few estimates for all the cities in the developing world, in the Grand South. Very few estimates we have for Africa, Middle East, South Asia. The data are updated every 3 months with a latency of about 3 months. We paid attention to evaluate the product against, let's say, more sophisticated but less frequently updated urban inventories. A good example is a Vulcan product from Kevin Gurney. It's very detailed, hybrid, bottom-up, top-down urban inventory, but it's only available for the year 2015. You can see the comparison here. Each first bar is our estimate, and the second bar is Vulcan. They agree well, but they disagree regarding the share of different sectors within the total emissions. You can also see in the bottom figure that for Los Angeles, for instance, there is a big difference between our estimates and Vulcan for the Los Angeles County, but here we hit the geography problem. For instance, when you look at the larger functional urban area of Los Angeles, we are in closer agreement. We also compared our estimates with the CDP kind of self-reported voluntary disclosure project of cities and with the CADS inventory, which has a lot of data for cities, but only in China. And we found that generally, although our estimates are kind of quick, fast-track activity-based estimations, we were on track with errors between 10 and 15% compared to other inventories, knowing that, of course, you have also uncertainties in what cities report, sometimes due to system boundaries or to different activity data. So what's next now? Now we want to produce high-resolution emissions with the same consistent methodology. We stopped at the regional or city area level. We want to go down to the building level or to the block level, to the street level, and we want to improve the latency. We want to try to have a latency of 10 days instead of 3 months. And we want also to extend the methodology in regions where you have no data. So not like Zurich or Paris or Berlin or Munich or US or China, where you have a lot of data. But in most of the cities that achieve a large share of global emissions, there is no data. So for this, we need to improve the proxy data, including the type of buildings. We need new methods for cities with no data. And once we have achieved that, we could extend the work to combustion pollutants like black carbon, CO, and NOx. And of course, we can make scenarios. This is fundamental because if you take here an example of Mumbai, you have 2 neighboring areas. One is a business district, the other one is a slump. And the same for Johannesburg at the bottom. It is clear that the difference of income is enormous among those 2 examples. And the question is, which one produces more CO2? For this, we need detailed spatial distribution of emissions. We need information on urban morphology, which doesn't exist everywhere. And only when we have that, we can provide, I think, policy relevant information for mitigation. So we use artificial intelligence for that. We don't have building level data everywhere in the world, but we make inference of building traits, building properties that are associated to their carbon intensity. We use new type of mobility data, such as TomTom congestion indexes, but also cell phone data to infer transportation emission patterns down to street level. And we have also a monitoring of point sources using satellite data, in particular the power plants that surround the city and deliver power to the city. Still, we have some gaps, like all the small industries and the small power plants, which are sometimes within cities. We cannot monitor them explicitly. So the challenge is that CO2 emission is an activity multiplied by an emission factor, more specifically a population times an activity per capita times an emission factor. We don't know the population. We have a global map of population at the scale of large district, but we don't know how many people live in each building. So this is the first challenge, how to map block level population accurately. And to do that, we use building morphology. We infer the volume of each building, the type of each building to put people in the right place. at the high resolution. Secondly, we need activity data. Of course, nobody measures emissions of each building, but we use proxies like nightlight, Sentinel-2, high-resolution imagery, pollutant data, land surface temperature in the night that we know is related to energy consumption. And we use that as a proxy for the activity intensity per capita for each building or block. And what we have not done yet is to characterize emission factors by crossing this information with surveys. That's why we are working a lot with the World Bank to use their surveys of poverty, which are unfortunately quite sparse in many areas. So we used training data, like we do for all artificial intelligence problems, such as OpenStreetMap. The problem is that you have very good OpenStreetMap data for Paris, but you have only 10% of Cairo, which is covered by OpenStreetMap. So you don't know the morphology of the other type of buildings in Cairo where all the people live. So what we do is that we train a model on the known height and the area of each building to generate a classification of the buildings, which produces height and type of building, if it's, for instance, agriculture or business or residential or administrative or commercial buildings, by combining the training data with a large set of high-resolution land cover, OpenStreetMap data, building footprint from Microsoft, VIIRS nightlight, climate zone, surface temperature, and optical imagery. And the result is working quite well. We have a coefficient of correlation between the test data set and our prediction with artificial intelligence models, which is on the order of 0.9, which is quite good. So we can predict the height and the volume of buildings for 6 different categories of heights, from very tall, if you want, to very flat, to very low level buildings, which are often related to energy use and poverty. And we make also a classifications of all the buildings into the different types that you see on the right-hand figure. Some of them are anecdotic, like, you know, churches, for instance, or stadiums. Others are more important, like commercial centers, civic buildings, and of course, residential buildings. And it's a difficult problem because, for instance, in a city, you have sometimes a downtown with skyscrapers, and it represents only 1% of the buildings. So the training set is relatively low, but still the accuracy of our model is quite high. And this is an example of a result for the city of Cairo. It's not yet at building level. It's a grid cells of 500 by 500 meters, but we also have the data at building level. At the bottom of the slide, you can see a little web interface where you can log in and explore the data for different cities. In Egypt, here you have the Great Cairo. The heat map, the color table indicates the emission intensity of buildings. And I have to point out here that what we map is the energy use, mainly the power used by buildings, which means that the emissions do not happen in buildings, they happen in power plants. But we allocate the emissions from power plants remotely into the building. So it's a kind of hybrid between scope 1 and scope 2. But with our model, we can do direct scope 1 emissions. We can do scope 2 and allocate spatially the scope 2 emissions to each building or each block. And then we have other type of emissions like industrial emissions. We know or we infer them for large industries, but as I said, cities where you have a tissue of small manufacturers, we are not able yet to quantify emissions from small manufacturing sectors. We have also a problem in cities like sub-Saharan Africa, is that sometimes there is power blackout, and you have a lot of retailers of power. You have people who have diesel generators. They just start them and they sell electricity to neighbors. And this produces emissions inside the city. It's also aggravating air quality problems, but we do not have, of course, any inventory of all the diesel generators in such type of cities. So right now, we have a data product for 6 cities in Turkey. The Turkish government, with whom we are working with the World Bank, was interested in middle-sized cities like Ordu, Trabzon, Konya. So it's about less than 1 million people. We are also working with stakeholders in Egypt. We have the Greater Cairo, which has a lot of satellite cities, Alexandria and Luxor, and Johannesburg and Itequini city. South African government is very interesting by the kind of service that we offer. It's a relatively large set of data. For instance, in our training data from global OpenStreetMap and OSM, the data where we know the type and the height of the building, it's about 1 million of buildings have been inventoried. And the kind of data augmentation that we perform uses fields such as the Microsoft Global Dataset, which is only the polygon, not the height of the building. They did a machine learning model to know the footprint of about 9 million buildings. So each of them are kind of mixed with our models to calculate the height. So our plan is to continue this work for Turkey, for South Africa, and for Egypt. And also we received a philanthropic grant for India. So we are going to produce the same data set, building level emissions for more than 100 cities in India with the Indian Institute of Technology in Mumbai and other partners, and also for more than 100 cities in China. This work will start in 2024. And if we know emission factors, because in India, the main problem is really air quality. So we want also to work with our colleagues to plug in emission factors for combustion pollutants. We cannot do all the pollutants in order to transform our near real-time, high-resolution, city-level inventory on a daily basis into emission maps of carbon monoxide, NOx, and perhaps black carbon. So thank you for your attention. In conclusion, we all know that we've been steering climate policy, in particular in urban domain, by looking in the review mirror. A number of advances using both activity data. They have been spurred by the COVID research and big data, including satellite and large data sets, now offer the possibility to provide kind of more agile and lower latency emission systems. There are errors, of course, nothing is perfect, but it can serve two types of usage. It can provide to operational systems like what Frédéric and Richard presented, I think more accurate and more timely data about the variation of emissions. You can study the city metabolism, how extreme events like heat waves, cold waves, but also vacations, economic downturns are affecting emissions. And it can be used also to make scenario. If you have a map of emission at building level, you can tell to the city government, look, these are the low-hanging fruit for mitigation. If you spend 10% of your money on 1% of the building, you will achieve a greater emission reduction than if you spread the money on all the district. So this data can also be used for targeting urban planning. And this is mainly the aim of what we want to do, or what the World Bank would like to do with the data that we provide with their support. So thank you very much for your attention. Happy for answering any question if you have.
Thank you so much, Philippe. There are some questions for you in the chat. So if you could respond there, that would be wonderful. And just out of time considerations, maybe just one comment, actually, the data sets that we also are using for climate risk and vulnerability assessments, looking at building types, building heights, might also be a nice interface with the data that you're looking into. So we can maybe make some connections there as well. That's super exciting. Thank you so much. Now we move over to Dr. Roxana Petrescu and Dr. Glenn Peters, who will be co-presenting on the decision support blueprint. So lady and gentlemen, over to you.
Thank you so much. Good afternoon, everyone. And thanks, Marijke, for your kind introduction. As this is the last presentation before discussions, I will start presenting an overview of the COCO2 user activities. And then I will allow Glenn to explain the concept behind our desired COCO2 decision support blueprint, who will basically integrate these efforts you've seen already in our previous presentations. Next, please. In the context of the future CO2 emissions, the role of observations is key to real-time information, and both direct in situ observations and indirect observations from satellites are critical for this for the success of such CO2 service. And in this context, the users play an important role in the design phase, and therefore we give attention to the science via the Copernicus program, and we link the global link to the global organizations and initiatives as WMO, IGIS, and especially to national inventory agencies in charge of official reporting to the UNFCCC. And with this setup, we hope to strengthen the link between these communities at all scale and purposes. Next, please. Work package 8 and the user package in COCO 2 gives particular attention to users, and the main objectives are the identification of user needs to serve the submissions in a policy-oriented framework. We aim to design a set of information products that can meet user needs and provide this outline for the decision support blueprint. We produce yearly synthesis of CO2 and methane observation-based emission estimates. And we started to compile as well a catalog of satellite hotspot detection studies, as Frederick showed before, for the CO2 and methane. We identified as users mainly the national inventory agencies and the national policymakers, and the IPCC, scientific bodies, Copernicus and CAMS, and we hope to get more involved next to the city with cities, authorities, and the local governments as part of these important initiatives like IECLE and the Covenant and the C40. Next, please. What we do for the users for the moment, for national users, we compile yearly, as I said, we compile yearly CO2 and methane budget reports, assessing and weighting consistent evaluations of the reported estimates against observation-based estimates produced in the COCO 2 projects, and which is also linked to the previous Verify projects in which we initially started this reconciliation activity. And we hope to link further with the new EU-funded projects, Corso, Avengers, iClima, and Paris, which started this in the beginning of this year. We participate as well in different groups, initiatives, as listed here. And as mentioned before, for subnational users, we started compiling this catalog of studies. I will show you in a couple of slides a little bit more about this, and as well these targeted workshops as today. Next, please. Why is verification needed, and why we try to do this is because this verification ensures reliability with the inventory estimates, and it includes both inventory and observation-based estimates, complementing inventories and hoping to support both inventories and the scientific methodologies. And our current challenges refer to differences between these estimates from observation and inventory-based emissions for different greenhouse gases. And it is known that each greenhouse gas comes with different uncertainties, and we are trying to untangle and explain these differences. Next, please. On our ongoing work refers to primarily to identify and quantify and explain these possible divergences between global inventory, atmospheric inversions, and process-based models, and the inventories submitted to the UNFCCC. We build up on the methodological approach already developed, as I said, in the EU-funded Verify projects, and some greenhouse gas synthesis we published so far. For the CO2, we mainly focus on the EU27 and some individual member states, and also within the COCO 2 project. This will end this year with another synthesis. And on EU27 and global emitters like Brazil, China, Congo, Indonesia, Russia, and US, we try to explain the similar things for the methane. What we will do next is to set up this reconciliation exercise to support monitoring and verification activities, and we hope to open and maintain a dialogue between the analysts and the data providers and modelers to via this decision support blueprint we are trying to put in place. Next, please. As previously mentioned, activities for subnational users include for the moment the compilation of this catalog of published studies. It is presented as an interactive map with example studies of hotspot emission detection, mainly from satellites. It has global coverage, and it includes studies as those presented by Frederic earlier today. And it looks at the activities for CO2 and methane. And here it's an example of CO2 studies, for example, from cities, power plants, and or methane from oil and gas, or also natural events. And we hope it serves users to know better what satellites can do, and how can these tools might help identifying these events, and which are not always covered by inventories. Next, please. For national users, our activities include mainly compilation of methane and CO2 budgets, and as a verification tool in confront to UNFCCC submissions. And here is an example of ongoing work where we look at the EU and the 6 major emitters, global emitters. We're trying to identify the sources of methane and see anthropogenic, natural, and compare them with top-down, with the inverse estimates, regional or global. And then preliminary results show pretty good comparisons at the level of total emissions. Of course, some inventories also disaggregate and present emissions per sector, but for satellites, for example, we know that this is a little bit more difficult, as it was explained already by previous speakers. So we try to understand the gaps in the beginning, looking at the total emissions, and then to investigate where the differences come from. And it's important to know the role of the priors. It means the data which is initially as input used by the inverse models, and to try to understand what differences are based. Next, please. I give now the floor to Glenn, and he will continue with the CO2 activities and the decision support blueprint. Glenn.
Hello, everyone. Thank you. So I'll continue on a little bit with the national perspective, and then I'll move over to the decision support system. So as Roxana just presented the sort of country level methane comparisons, this slide here is showing country level fossil CO2 comparisons, so CO2 emissions from fossil fuel use and industrial processes. I'm not going to go into the weeds of every figure and line here, but just broadly speaking, on the left-hand side, we're comparing a bunch of estimates of global CO2 emissions from different sources, and you can see there's a bit of a spread there. Some of that spread can be explained by differences in things like system boundaries, what's included, what's not included. The figure on the right, it might not look like it, but it actually brings some of these estimates closer together by making them more consistent. So an easy example to show you or to explain to you would be things like cement emissions. Some data sets might include cement, others might not. And if you want to compare them, you really need to make sure you're comparing consistent things. When you do these detailed comparisons, you do discover some errors or mistakes or oversights, if you like, and through this process we have identified a few things which have been since corrected or updated. So this is just sort of continuing on showing some of the comparisons we do at the country level and global level, and which you can also do at the city level. Next slide, please. Looking at land use emissions is much more complex. There's a lot more complex processes that are going on so land emissions would be, for example, emissions from forests, where you have the forest as both a sink, in some parts it might be a source. It may be near a city, and so there's lots of different carbon fluxes which make it more complex. Because it's a natural system, there's also a lot of variability in terms of things like it might be a wet season, it might be a dry season, there might be a drought, there might be floods, and this can have an effect on the emissions as well. So comparisons are much more difficult. Historically, we've generally looked at the global level, and so the interest in verification and smaller scales means that we're going down to the country level and smaller, but then you need to worry about additional fluxes. So you may have some what's known as lateral fluxes outside of your region. So agricultural production in some regions may be exported. So we need to account for these sorts of things when we do these regional budgets. I'm not going to go into all the lines on this figure here, but that just gives you a bit of an idea of some of the things we're doing and issues that we need to deal with. If you go to next slide, please. So now I'll just talk a little bit about the decision support system or blueprints that we'll develop through the COCO 2 project. The figure on the left there shows a general framework and process for how you may estimate emissions from observation-based systems. And so on the far left, the boxes there show a variety of observations, not just satellites, but you see in situ or surface observations, meteorological observations like wind, and through all the presentations you've heard these things mentioned. So these are a very important component of the system. We need some prior information, so we need to have some initial estimate of what we think the emissions may be. For example, what Philip presented on the city level carbon monitor emissions, that may be some initial estimate that we use together with the observations to try and improve the estimate using the observations. This middle box there is integration, where you might have an inversion system or a model which translates the observations and compares them back to the prior information, or gives us a new estimate of what the emissions may be when you consider the observations. This is all very complex, and this is largely what the scientific community is doing, and this will become an operational process. And then we come to the top right box there, which is the decision support system. And this is where we would hope to and expect to, let's say, interact with you guys looking at, say, city level emissions, or others looking at country level emissions, and so on. This may be a point where you would extract data, have tools that you can use to analyze the data, and so on. So what we're doing with this blueprint is trying to look at that top right box and what that may look like. Next slide, please. So we have a draft blueprint out at the moment. I'll give you a link in a few minutes. Where have we got the information on user needs for this report? There's a few different elements of information that we can gather along the way. So there's meetings like this and interactions with organizations like ACLEAR and so on. The IPCC, through their guidelines, already have some guidance on verification using observation-based approaches, and some countries are already utilizing this in their inventories. This is at the country level, but over time we can move down to smaller scales. Various research projects have involved users, and there's been some quite useful interaction and lessons learned from both sides. And you've heard a few projects mentioned today which are continuing, which will keep these activities going. Another example is a Verify project, which is now finished, produced a lot of sort of fact sheets, which in a sense brought all this data into a common platform. There is so much data coming from all these different models and activities. And so to be able to compare them, we need to have them on a common platform. And the IPCC is also further interested in developing these tools as well, elements of verification. And so there's a community that's continuing with these activities. So this is sort of gives you a bit of an idea of where we've got the background information to feed this decision support system, but we're hoping to get more information and much stronger user perspectives in the coming months when we revise this. Next slide, please. So some of our preliminary recommendations, I just sort of give some broad brush bullet points here. The first one, perhaps obvious, is building a common knowledge base. When scientists and users interact, they're often speaking a different language. I'm sure many have come across this, and so it takes some time to get to a common platform, understanding what the opportunities are. Let's say, what can satellites offer, what can't they offer, what are the expectations, and so on. So these are very important things to figure out at the start and discuss at the start to make sure that we're on the same footing. Communication is quite an important point here. If we talk about satellites, or people don't know what we're talking about, or they think that, oh, well, these satellites will just be able to estimate everything straight away. We don't need to do inventories anymore. So this comes back to the opportunities and expectations and how they're managed. Case studies are quite important, and we're seeing through these projects and several of the presentations today where there's activities ongoing, and by doing these activities we learn which systems may be better in which context and so on. So continuing this at city level, at country level is very important. Further development of inversion modelling, I won't go into the details here, this is more for the scientific community on the tools that they're using. Accessing graphical material and analysis tools is another important element. So some examples you can see already from the Copernicus Atmospheric Monitoring Service, CHEMS, which is mainly for air pollution at the moment, will be extended into greenhouse gases. That would have different elements such as accessing data to perform your own analysis, while others might prefer analysis tools or pre-prepared results where they can have the analysis more or less done for them, or a part of the analysis done for them. And yeah, the sort of obvious thing here, collaboration across these different research projects. So you've heard different people speaking today from different projects and working on slightly different questions, and it's important that we all continually come together and share notes and make sure that we're building the best knowledge base to help user communities. Next slide, I think, is the last slide. So there's a few links there which you can look up later. As Roxana mentioned, there's the catalogue of hotspots to give you some more information. We have this preliminary blueprint available for the decision support system, and feedback on that is very much appreciated, particularly on the user perspectives angle. We have these country level budgets report available, and if you have any questions or would like some more information, then please contact myself or Roxana. And next slide, I think, is the last slide. So I think we're finished. Thank you.
Fantastic. Excellent. Perfect timing, people. You guys are, I'm very proud of all of you. You're very, very good with timing.
That's a miracle if scientists keep on time. So
great. So I would propose, are there any clarification questions on the last presentation? Maybe just a show of hands again, if in case you do. And Kata, if you can just help us check there if there's anybody with a question. Okay, I cannot see anybody with a question. So then I would propose, if we may, let's look at our Menti first question answer. Who is in the room? Just to give a quick snapshot of who we're speaking to before we actually start our discussions as well. So quite a nice mix, actually. And definitely not everybody has completed this, because we have we have had a wonderful participation here with 89 people in total. So that's super cool. Of course, a lot of our academic research colleagues with 18 consultants also supporting our local governments with their greenhouse gas inventories and strategies, international agencies, local and regional government representatives, national government representative, several people from NGOs, and also providers of data or products related to local greenhouse gas inventories, and two mysterious people who we do not know who they are. Great, that is so helpful. Thank you. And we have another question coming up now, if we can run the second Menti question, and then we'd like to ask for your engagement there. Can my colleagues help with this one? There we go. What would be most helpful in a decision support system? And I know it's a bit premature to ask the question, but because we will have this conversation now, but maybe also if you can give your perspective, what you think would be most helpful, that could also inform the direction of the conversation we're taking at the moment. So the options are access to raw data, tools to estimate emissions in a given region or city, process results comparing city level estimates from different methods, or process results comparing city level estimates from, well, that's the same one. So we have three questions there. I think we're missing one question, which was maybe framed a little bit different, but nonetheless, it seems as if people are definitely linking to this tools, angle and process results, access to raw data. I think we've seen the problem globally. Of course, we're in Europe with all the satellite data and all the other funding that has been put into the space of developing more robust approaches to greenhouse gas inventories. There's been a lot of movement, but we do see that big gap. And I know the ICLEI teams and our colleagues from C40 and other organizations, including WRI, we've worked very hard to try and show where the data can be found. But again, we need to get the things, we need to connect the dots here. And I think this conversation of developing a useful decision support system is so timely, especially as we need to step up that MRV angle, measuring, reporting, verifying, having robust data that can inform action, as we've seen from the Porto Alegre case as well. Great, so I think let's open the conversation. So Richard, if you would like to step up with me and we can start the conversation. So people, I would propose, again, raise your hands if you wish to speak. We really would like to also hear from you as far as we can, but we'd love to have this now a useful in-depth conversation. You've seen what is on the table. If you can still recall all of that, I don't know, but I think you have the pointers. So again, in this conversation, we know not everybody is a greenhouse gas inventory specialist, so that's fine. All your questions are valid. We really would like to understand from you, if you're a political leader, what would be your perspectives? If you're a technical person, what would be your perspectives? Everything is valid and very helpful. And I see we've got our first question from Paulo Bertoldi. Oh, Paulo, wonderful to have you online. Let's try and see if we can access and that you can speak and share your thoughts. Paulo, over to you.
Yeah, thank you, Marijke, and congratulations for setting up such a very interesting workshop. Can you hear me? Hello?
Yes, we can.
So, yes, so thank you again for this very interesting workshop. We are trying to use the EDGAR database and downscale at the urban level as an alternative to do an inventory based on scope 1, scope 2, as in the GPC and in the global covenant of mayors. And our result that we put in a paper submitted to a journal, so it's not yet confirmed by reviewers, is that there are downscaling the EDGAR database could be a good proxy for emissions. So maybe a suggestion for other researchers to we can share our draft paper if interest to get comment and see basically that we more or less can guess the emission from a city with a simple method. Because as you know, Marijke, smaller cities globally, even in the EU, have problem to identify their emissions. And if you don't have emission data, very difficult to plan. So just was a piece of information that can be added on to today's discussion. Thank you so much.
Thank you. And just for you, those of you who don't know Paulo, he's from the Joint Research Center from the European Commission. I'm checking, I'm not seeing more hands. Maybe in the meantime, if there are no questions coming in, or any of our experts on the panel, would you like to give your perspectives of what you think to try and lead the conversation? Let's get this conversation moving from an expert perspective then. Put your leading questions in, and then we can see if there's a resonance as well, because we need to understand from all the different parameters and angles as well, of course.
Okay, Glenn has raised his hand, as well as Sergio from the attendees. I don't know which one should go first.
Whoever raised their hand first, you're the
Glenn.
lady in charge there, Kata.
Glenn was first then.
Yeah, sorry, I'll just be quick. I was just going to respond a little to Paulo's comment. And so EDGAR, the database may work well for some cities, it may not work for others. It's going to depend a lot on the various proxies they use to locate data. Just to give you, or to locate emissions, just to give you an example, at least in an earlier version of EDGAR, the oil and gas facilities in Norway were based on a default proxy of population. So all the oil and gas facilities were in Oslo and not in the North Sea. So you just need to be careful that there's approaches like Philip was talking about, using more information as well, but ultimately we want to move to a system where we can incorporate a lot of the best data which is collected. So many statistical offices around the world, for example, will have information on point sources, they know the road networks and so on. So that data is not always easy to access. It might have some confidentiality issues and so on. But in a longer term perspective, if this data can be used and national groups pull it together because they know their countries better than what an EDGAR expert would, for example, then that's sort of the direction we need to head, I think, incorporating a lot of the really good statistical data we already have in many countries. That was just a comment.
Maybe if I can just, before you get the floor to Sergio, just to comment on this or complement this. Because within CAMS, we have been working with the JSC and with the EDGAR database for quite some time. It's one of our important inputs, but indeed, there are always things that can be improved that are not quite correct. And actually, the beauty of using these kind of inventory data sets, and also within CAMS, we are further developing these to make sure we cover all the pollutants, all the greenhouse gases in a consistent way. But using these data sets and then comparing this with actual observations from satellites and in situ networks tells us exactly where there are differences between the different information streams. So bringing this together in one system immediately shows you what Glenn was talking about, that sometimes there's just things that are not quite correct and that need to be improved. So it's not even it's basically bringing things together to collaboratively improve things for the future. Just wanted to add that to what Glenn was saying.
That's actually very important, Richard. Also, from the perspective of ICLE and our partners, we also want to make sure that our local and regional governments are served with really well packaged information, data, modeling opportunities that eases their burden, because these people actually have so much work to do. And we need to make sure that their life is made easier and that data flows faster, more efficient, and also that bottom-up data is incorporated. That's where we're trying to get also using that bottom-up inventory system to make sure to do a quality check, again, also whether the national inventories aren't making too many assumptions, and trying to move away as far as we can from too much disaggregated data that isn't verified. So we have a number of angles that are important there. Then Sergio, the floor is yours. You have a question or a comment.
Sim, bom dia para todos. Estou muito feliz de estar com vocês, ouvindo suas palestras, e quero parabenizar todos pelas suas experiências. Gostei muito do trabalho do Felipe, no qual monitorou 1.500 cidades. Isso nos interessa porque são muitas cidades ao mesmo tempo, e nós temos dificuldade de monitorar nossas cidades aqui na Amazônia. A Amazônia é muito longe as coisas, e isso torna difícil a gente ter contato com os dirigentes das cidades. Mas a análise do trabalho do Frederic, eu tenho dificuldades, não é minha área de interpretar essas imagens, mas me pareceu mais fácil, já que eu vi uma imagem que ele projetou e apareceu os pontinhos vermelhos justamente na Amazônia, que é onde nós temos as maiores emissões de carbono no Brasil, basicamente devido às queimadas que fazem na floresta amazônica, né? Isso foram as maiores emissões de carbono. E, por fim, eu queria parabenizar, né? Existe uma cidade que é semelhante à minha cidade onde eu moro, na Amazônia, que é Belém do Pará, uma cidade de tamanho semelhante, população semelhante, que é Porto Alegre. Eu queria parabenizar a Rovana pelo avanço, né? Nós já estamos muito atrás, vamos fazer o nosso balanço de carbono desse ano. E queria dizer a Rovana que, dentro de uma semana, nós teremos um encontro nacional dos secretários do meio ambiente, né? Eu estarei lá, e eu espero que você esteja também, né? Para a gente poder trocar ideias sobre os avanços que a gente pode fazer nas capitais brasileiras, né? Então, eu tenho umas dúvidas, e aí a gente pode conversar lá, o secretário do meio ambiente também, se estiver lá, né? E e eu quero desejar, então, parabéns a todos. Eu queria receber material para que eu possa estudar o trabalho de cada um, se for possível, as apresentações. Obrigado.
Right. Thank you so much, Sergio. I think it's also important, listening again now from a local government perspective, we need more projects. So I would highly encourage the World Bank clearly has shown a keen interest. Let's discuss jointly with the World Bank. I think there are opportunities with national governments and the big donors to step in and step up and scale up as well to make sure that the local support is reaching that local government level as well. So that's a very, very point well taken. And again, remember our colleagues online, our politicians are really well connected. They're connected. They have regular meetings with different line ministries, different donors. So there are big, interesting potential opportunities to scale up and step up, whatever it is that we're co-designing here as well. Are there any more questions coming in?
I had a comment, maybe.
Yes, over to you,
I
Philip.
think cities have a lot of emission hotspots, which are not well known. And I believe that the current global data sets, for instance, like EDGAR or even Vulcan, they are using a relatively coarse resolution proxy, like, as I explained, population density. If you have it on the scale of a district, in the same district, you can have a slump and a business district. So I believe it is important to combine kind of classical data sets with this new satellite imagery, the Microsoft data about buildings, because classical data, they are not very complete also. For instance, there is a global road data set that we were using, and we found that there is a report and a data set from the United States CIA. And the CIA has about 5 times more road in Brazil, for instance, including dirt roads, than in the global open road data set. So I believe it is really important to try to help by using a high resolution data set at building scale, but also for roads and also for small power point sources. We have a methodology for roads and for buildings, but we kind of are stuck a bit with the small point sources that prevail in many cities, like small heating plants in cold countries or small industries that emit a lot of CO2, but we don't really know where they are located.
Okay, but these are bottom-up data sets that we can provide as well. So that's where the integration of different data angles could come in as well. Okay. Rovana, over to you.
Quero agradecer, Sérgio, pelo teu feedback. Porto Alegre realmente tem trabalhado em muitas ações. A gente não vai estar presente nesse evento, nem eu, nem o secretário, mas estamos abertos para qualquer troca. Tudo que tu precisar, vou deixar meu contato. Acho que depois nas apresentações, aí, quando o pessoal divulgar, tem o meu contato ali. E o nosso desafio agora é começar a mensurar, né, todas essas ações. A gente deu o primeiro passo, que é começar a fazer mesmo sem saber exatamente o quanto isso está evitando de emissões. Mas agora a gente vai para o segundo passo, e eu acho que todas essas informações da apresentação de todas as palestras são importantes, pelo menos se a gente conseguisse ter um overview geral de quanto isso está reduzindo, já ia ser super importante para a gente continuar seguindo nessas ações.
Thank you very much, Rovana. Maybe a question back to you, Richard. We are talking about a global service that we're looking at. This is beyond Europe, correct?
That's correct, yes. So it's funded by the European Commission. The ambitions that were set in terms of greenhouse gas monitoring were set by the European Commission as well, sort of in reaction to the Paris Agreement. So European Union member states are one of our main focus points, but Copernicus is always also considering the rest of the world, because we really believe in sharing data. All data is free and open, and we really want to interact with well, other service providers around the world, but definitely also users around the world. So yes, for us, it's important to connect to different countries, to different cities around the world. This is clearly within scope of what we try to do.
Mm-hmm. Okay. And a second question, very pragmatic question: are we talking about potential free services as well? Because we know the local and regional governments struggle financially sometimes. They have they essentially, as a level of government, we would expect free access to data. And in many countries, they still have to pay for access to the data they need to develop their greenhouse gas inventory. So that is for us something we're really tackling and trying to avoid. So I know somebody has to finance this, but the European Commission, I believe, is the one to do that also over the longer term. So if we're talking about free services that can, where we can pull the data potentially into our existing greenhouse gas inventory tools, like ClearPath, like Heat Plus, like Waycarbon, that could be an interesting angle. So we would need to have some bridging mechanisms where the existing tools could layer that data to, again, make it easier for the user who doesn't have the time to bring all the data sets together, or have universities to bring those data sets together, and make sure that we can serve in a quick, easy, straightforward manner. And using the different layer sets, I see there are questions that, also a question that came in, a colleague who asked information about the spatialized, where the spatial data, how that comes across from looking at the sectoral data and then the urban building typologies. I think that was a question for Philippe. But again, I think that's the challenge we're dealing. We need data from so many different angles on so many different sectors. And the robustness of data is quite often challenging, that it isn't robust enough, which means our inventory results are not always optimized. And we know every new inventory a city develops, you're getting more access to better quality data. So we'll improve step by step. But I think the satellite data layer and the modeling support services could potentially substantially step up the understanding on making policy choices and investment choices in the city. And that's whatever we design, if we can do that, that would be helping our local governments around the world 100%, because that's the piece we are struggling with, definitely.
Yes, thank you for that, Marijke. So within Copernicus, all data that's being produced, made available, is free and open. That's the core of Copernicus, with the caveat that we can't do it all. We have to focus on what we do best, so for instance, going in if I look at existing air quality services, going into the highest level of detail, we don't do that. We leave that to what we call the downstream sector, which can be nationally funded or locally funded, or businesses to take that further. So we tend to focus more on global regional domains. For greenhouse gas monitoring, we are still trying to find the best way there, because there it's also clear that local information is equally important. So looking at cities, looking at industrial complexes. So in principle, it's still within scope, but it all depends on the user requirements. So getting feedback from you about this, well, what are your needs, is critically important in this phase to really fine-tune what we do in the end. Our budget is limited as well in the end. It's a good budget, but it's limited. So we have to make choices. But in the end, what we do is then free and open, and we try to share this. And then also, as I mentioned before, we try to collaborate internationally with other agencies around the world. This week, WMO, the World Meteorological Organization, their Congress approved a global greenhouse gas watch program that really tries to bring together the different players on this. So we work effectively together in order to best serve user communities at the local and national and regional scales.
And I know the COCO2 project specifically looks at carbon dioxide. I think we had that conversation, and it was good to see people mentioning methane and other greenhouse gas emissions. We need to get that full spectrum picture as much as we can as well, through whichever data possibilities there are, and considering. Certainly for me, methane has been high on the priority list because of the potency of the gas, of course, as well. I still do not see hands raised, so let me just double check. Any other questions or comments, also from our expert panel, if you will?
Yeah, maybe just to repeat in a way. So for us, it's important to to be aware of what are the challenges in cities in getting their hands on the data they need to monitor their mitigation actions, or what information are you looking for us to then respond to see what we can actually help with and what is just not possible with observation-based information. Also taking into account that, as you heard today, we are coming from different angles. The work that Philippe presented on activity-based data, the work that Lucas and Frédéric presented using observation. So we trying to go at the problem from different angles, but still it's important for us to need what are the gaps currently in terms of monitoring, especially emission mitigation at the local level.
Great. For any of our local or regional government representatives online, would you have any sharing that you would like to do on your challenges in accessing data and what kind of data and information you're looking for? Difficult not seeing the audience, though, I must say.
Maybe if I rephrase it a little bit, because now we have this workshop, 3-hour workshop with, I was really pleased to see indeed 80 or 90 people attending. So really pleased with that, that there's this interest. But I also know that it's always hard in such a workshop to come up with specific questions and requirements. So maybe a better way to phrase this is, how do we take this further? How do we interact? How do we get to better know what is needed in cities around the world, and how can we facilitate that? Obviously, ICLEI itself plays an important role here, but can we do a little bit more than just having these workshops every now and then, and try to get a better idea of how we can link the different efforts?
Well, I can speak for ICLEI, and I have several colleagues online from our offices, Africa, Canada, US, and now Latin American colleagues. So we will definitely deepen that question, and we can also collectively give you feedback from our experiences working with the cities, and that we will do in any case. Also with the GCOM and the conversations with Paulo and other partners in the Global Covenant of Mayors, which covers a span of 10,000 plus cities of different sizes. I think the city typology comment, for me, that was a piece we need to unpack city typologies, I think, in a much better level of detail, because smaller cities would not put so much attention on developing a robust greenhouse gas emission inventory, and other neighboring cities could potentially do that for them, so that one eases, again, the burden of the local governments themselves. So we can think of different constellations, but the city typology is important also, not on purely size. I think, Roxana, also we need to look at the industrialized cities versus the more agriculture or forestry. Amazonian cities have a very particular space, and very different challenges, of course, compared to an industrial city. And these, I think, we can bring into our conversations as well. There is one question that came in: how far away are we from an integrated system between all the different databases proliferating everywhere on greenhouse gas emissions, and looking at an integrated system that offers a coherent method for emissions accounting at city level? I think that's exactly what we're trying to discuss. So, but actually, that's the question: is how far away are we from this? Maybe.
Yeah, I mean, that's of course the ultimate question. So if I speak from the Copernicus angle, there we have set ourselves a clear pathway where we want to be operational, as all the Copernicus services are, but we want to be operational for this part in 2026. This is linked to the launch of the new constellation of CO2 and methane measuring satellites that I think Frédéric mentioned. So this will be the initial system, and will still be further improved based on a new user requirements, changing user requirements, but that's the ambition we have. In the meantime, though, there's a lot of work already going on in the different projects. Copernicus always sort of says we take the latest science and turn it into operational services, give it a framework with a long-term view. So that's what we try to do. But in parallel, there's all the science activities that are doing things, and you've seen several examples already what's happening right now. We also work closely with ICOS, for instance. ICOS Cities is just one of the projects which is very much focused on the cities. What do we need to properly monitor emissions from cities? But ICOS is also doing more than that. So yeah, we try to work, well, not try, we work with ICOS on these different aspects, and again, internationally as well. So a full system that can do all we need, we probably don't know when or if, but there are clear steps on the way where we are now, where we want to be in 3 years, to at least have good monitoring systems that have a long-term view, long-term sustainability to help cities and countries.
So I think that question actually summarizes the need. We need something like that. And I think we can also prove that through the work we're doing collectively with our partners, with the other city and region networks as well. And I think it's linking back to this conversation that I started with the race to zero. The race to zero, we need to move towards climate neutrality. Apparently at the moment, they say 2050. I believe 2050 is too late for that, probably because we're not on track. So we need to move to climate neutrality earlier. And this means pushing down emissions as fast as we can, as rapidly as we can, as efficiently as we can, but we have to know where to act best, and that information flowing to policy and decision makers at the local level and at the national level will then inform investment decisions. For me, this is clear. We have to get this up and running. And for ICLEI in particular, we'd be super keen to explore this conversation on our own emission inventory tools that we're working on, how to bring those data and layered data sets together. There are quite a lot of tools, well, actually not that many even, supporting local and regional governments around the world. So ideally, if we can get that interconnection with those tools to help. Some are a business model with companies making money off that, but that's perfectly fine. It's a legitimate business. For others, like city networks, we do this at a very low cost, basically just covering our costs. And I think it's very affordable if we can find a global system and a global solution there, of course, as well. Just checking again. I don't see any questions further, but I do see Lucas's hand is up. So Lucas, floor is yours.
Yeah, maybe I just wanted to add, I mean, we all would like to have an integrated, universal, homogeneous system. And that is certainly good. That is a target. Satellites will certainly help. Statistical information, as Philip mentioned, will be of tremendous value. But that does not avoid us having local activities, looking at the very local systems. Philip mentioned generators that are used in under certain occasions, transportation, which may be very individual, very different from one place to the other, wastewater treatment, which may be very different going from one country, one continent to the other, and so on. So I think that the local activities and identifying the local important sources and quantifying them is something that we have to provide on top of the very large scale and unified systems.
Thank you, Lucas. There's a question that came in from Bogota. I find that one of the most relevant limits detected for the environmental authority in Bogota is applying validation methods to the local inventories using their monitoring system. Also, again, I think linking back MRV, the verification piece is difficult for the subnationals, also because that also makes it more costly. But does anybody have any comments on that? Applying validation methods to local inventories.
This is Glenn. I was going to have a comment which sort of links to that as well. And I think the question from Camilo and also the comment from Lucas sort of hits at this as well. So in the original question, there was the words, all different databases proliferating everywhere. And I think that's something that we've glossed over, but it's quite important. So as someone that works with emission statistics, I can tell you there's all sorts of databases proliferating everywhere. And I can imagine from the user perspective, well, which one do I use? I hear about this wonderful thing with, lots of money and whatever behind it I won't name anything, but is that data set better than whatever else data set? Is, you know, EDGAR better than the Global Carbon Project when it comes to CO2 emissions and so on and so forth? And so when you start to get all these initiatives with city level emissions, there's not going to be one. So I would think that whatever comes from the Copernicus system will be one of many competing. And this comes back to the question, which was about validation. So how does a user in Bogota, for example, know which data set they should use? And this is probably a question that we don't have a good answer to, other than saying, well, you should use our data because ours is always best, you know. But how do we validate, and how do we pick out which are the more reliable data sets over time? I think is an important question that we need to think about.
Well, that's also one of the things we've addressed, we meaning ICLEI, WRI, and C40, when we developed the Global Protocol for Community Scale Greenhouse Gas Emission Inventories, GPC for short. The GPC uses notation keys where you can also give a signal how robust is your data, or that we get a better sense of, or is the data just not available, or was it just purely disaggregated data from the national inventory, which then makes it for us rather unrobust. So these things we're trying to track, and I think it would be good to have another conversation with the technical guys from all our organizations and you to show what we've done and where we can show you technically where the gaps are. But this is a wonderful opportunity also to promote what we're doing, also to try and look at that robustness and transparency of emissions. We have a slide on integrity matters. We have a working group has been established, led by the Global Covenant of Mayors and WRI, to respond to the high-level experts group's comments and requirements to make inventories and action plans more robust. So Kata, if you could pull that up, that would be wonderful. And I just wanted to do a little bit of marketing. There's a survey link to this one. We'll send a link to everybody as well. But this is part of informing that particular conversation. So let's go to that particular slide. Excellent. Thank you so much, Kata. So again, this is an important piece of work where we collectively from the subnational governments and the network serving subnational governments are coming together to have a perspective where we review and reflect on the pledges and targets that have been made, which of course link to greenhouse gas emissions reduction perspectives. And in our view, we call that then moving towards climate neutrality, to go to ideally net zero emissions as much as and as far as we can, as it is in the mandate of the local or regional government. And this expert working group is looking also for what are the options, the recommendations we can bring into making guidance available and feasible actions for urban policymakers, and as well as our own network as well. So that's another survey we would like to promote. And the second survey is around the GPC. We are also going to support WRI is releasing that survey, is specifically also looking at, do we need to look at scope 3 in the greenhouse gas inventories? We touched on the different scopes in the different presentations. These conversations is basically around what responsibility the local government and the community take for their own emissions that they're generating or emissions they're importing through scope 3, for example. So there will be 2 surveys that we also ask the colleagues online to please comment on. We'd love to hear more from you in that regard as well. Thanks, Kata. You can drop the slide now. And I guess maybe then, Richard, shall we wrap up, or are there still any more comments or questions coming in?
Just looking. I think Philippe had his hand up, but it's gone. So I don't know if he still wants to.
Okay.
But otherwise. Yeah, let's wrap up. We're getting to the end of the workshop.
Yep.
So who starts?
Over to you.
So yeah, I mean, I've been really pleased with this workshop, and as I said, the number of people attending and listening. I think coming back to what Glenn just said about all the different emission data sets. His point is, of course, absolutely right, but I think a lot has been triggered in the last years and in coming years to make sure we actually exchange data and look at the different data sets and compare them and learn from them, understand them better. So I'm quite hopeful actually that with this whole drive towards climate mitigation with funding attached, not just through Copernicus, but also through other means, and trying to really keep talking together, discuss together, and try to improve the data sets. That there's a lot of momentum now going in the right way. So for me, that's really good. And it's important to keep talking. So that's why I raised this earlier. How do we stay in contact with cities around the world to make sure we understand what the gaps are, where we can support activities that are already ongoing, and how can we effectively work together on a local scale. Yeah, so far so good, I think, and still a lot of work to be done. That's clear. It's challenging. The science is at almost the limit. Probably the technology is almost at the limit. But we have to make best use of that and try to exploit that, because it's clearly well, it's one of our biggest societal problems that we are trying to deal with.
Exactly. Great. So thank you so much. I think from my side, also thank you for all the speakers and the participants. I think we're dealing with a very important topic. I think from ICLEI's perspective, we want to make life easier for our subnational governments. We want to automate as much as we can, get data sets and pre-populated inventories that are robust and good enough to take action on. Also, inventories don't have to be perfect. We know that, but we need to do this trade-off. How much time do we spend on developing an inventory versus how much time are we actually investing and acting on the ground? And more action is needed on the ground, and we need, because of that, the easier inventory space as well. So I think, thank you from my side. I think this second COCO2 webinar has been useful. We need to do some more homework, so we'll follow up with the homework, and also we'll get back to our own cities and regions in our own ICLEI network to also just answer those questions in a bit more detail, and asking people to test and share the links that have been shared to test also the decision-making approach there. So thank you so much, colleagues. Wonderful that we've kept so much attention for 3 hours, and it's really lovely to continue the conversation. From my side, thank you so much, and wishing you a wonderful weekend up ahead.
Thank you.
Thank you so much. Thanks.